All right, Algebra 1B students, welcome to part 2 of lesson 8.2. Today we're going to talk about factoring a polynomial. We're going to be starting on page 493, but before we even get there, we're going to look at these two warm-up problems where we're just going to rewrite these long strings of variables and numbers being multiplied together using exponents. So I hope that it is review for you that x times x times x times x, when I have 4 x's all multiplied out together, that means x to the 4th power. X to the 4th power. So in the second one, number 2 here, when I have x times x times x times x, again, that is x to the 4th power. And then I'm timesing that by 2 times 2 times 2. That's 3 2's all multiplied together. That's 2 to the 3rd power. So this is equal to 2 to the 3rd power times x to the 4th power. And now 2 to the 3rd, if we were to simplify that, that would be 8. 2 times 2 is 4, times 2 again is 8. And still times x to the 4th power. Right? So when we have long strings of multiplication of the same thing repeated, remember that we can rewrite that with an exponent. And part of what we're going to do today is actually do this process backwards. Go from an exponent back to listing out all of these things that we multiplied together. Right? So if we look at page 493, our first job today is to find what is called the greatest common factor. I'm sure you have all at least heard of that back in middle school, greatest common factor of two numbers. Now, we're going to do the greatest common factor of a bunch of monomials that are all strung together in a polynomial. Right? So, for example, we are asked to tell what is the greatest common factor of 5x to the 3rd, 25x squared, and 45x. Our first step to figure that out is to list all three of those terms as numbers multiplied together in a big, long string. All right. So, for example, 5 times x to the 3rd. Well, that is 5 times x times x times x, right? 3 x's, that's x to the 3rd. And we're timesing by 5. So 5 times x times x times x is 5x to the 3rd. 25x squared, if I want to factor it out as much as I can, well, I know that that is 25 times x, but hopefully we know that 25 is really equal to 5 times 5. So I've got 5 times 5 times x times x. Right, I'm just listing out every piece that I'm multiplying together here. Right. And lastly, I have 45 times x. So I know there is one x involved there. And I know that 45, or at least I hope we know, that 45 is 5 times 9. But now 9, I think I can factor again, correct? I can factor 9 into 3 times 3, still times 5, and still times x. So now I have factored out each one of these terms to what they are in their most factored form. In their most factored form, right? Now the next question for us is which of those factors are common for all three of our terms? Well, let's start circling the ones that are the same. I see an x, certainly in all three of them. X, x, and x. Right? I see another x here, and another x here, but I don't see one over here, so that doesn't count. I see a 5 here, and a 5 here, and a 5 here. And I think that's it. I don't see any 3's here or here, no 3's. And that's all that's left over here. So the things that are common are 5 and x. Right, so what that means is my greatest common factor, or GCF, is equal to these two things here multiplied together. 5 times x, or just 5x. That is how to find the greatest common factor of a polynomial. You list out all the terms of the 3 pieces, or 4 pieces, or 2 pieces, or however many there are. Find the ones that are common, and multiply all the common ones together. All right? Now, I would like you to do that process for this polynomial, which you can find pretty much right in the middle of page 493. What is the greatest common factor of these terms? 3x to the 4th minus 9x squared minus 12x. Now, what I will say is the greatest common factor should always be positive. Always be positive. Because if it's not positive, that means we're below 0, which I don't think is our greatest number. Greatest means above 0. They should always be positive. All right, so pause the video, take a look at got it number 2 on page 493. When you're ready, come back and we will factor out the greatest common factor of a polynomial. All right, once we find the greatest common factor of a polynomial's terms, we can factor it out of that whole polynomial, all right, and create what is called the factored version. Now, when we get to the end of this, this will look exactly like the opposite of yesterday. Okay? The opposite of yesterday's. First step, step 1, is once again to factor each term. So in this example where they are asking for the factored form of 4x to the 5th minus 24x to the 3rd plus 8x, I'm going to factor out each one of those terms first. With the 4x to the 5th, I know for sure that there are 5 x's, 1, 2, 3, 4, and 5 x's. And I know that 4, I can really write that as 2 times 2. So I've got 2 times 2, that's 4, times x times x times x times x times x. That's factored out. Now, I have a minus 24x to the 3rd, but I'm not going to worry about the minus right now, just that 24x to the 3rd piece. And I'm going to list out all the numbers I can multiply together to get that. I know that there are 3 x's, x, 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 x to the 3rd. And now numbers for 24. Well, I think I can do 6 times 4, certainly. But I think I can factor those again, so I'm going to do that. 6 can factor to 3 and to 2. 4 can factor to 2 and to 2. So really I have 3 times 2 times 2 times 2 times x times x times x. Right? And then finally, 8x. I know there's just one x involved here. 1x. And for 8, I think I can factor that to 4 times 2, which I can then factor again to 2 times 2 times 2 times x. So here are my factored forms, my factored terms, I should say. Here they are, big long strings of things all multiplied together. And now again, I am going to find the ones that are common. So I'm going to call these common factors CF. Well, I see an x here, I see an x here, and I see an x there. I don't see any more x's in that third one, so I can only take out one of those x's. So x is a common factor. I see some 2's that are common here, here, and here. So I know I have a 2. And I think I see another 2 that's common. I can take a second one from there, a second one from there, and a second one from there. So I have another 2. But that's it. That's all I have that is common in all 3 of those terms. An x and 2 2's. If I multiply those together, 2 times 2 is 4, and I have that x, 4 times x, that is my greatest common factor. Right? Greatest common factor is 4x. Now, step 2 is to factor out the greatest common factor. Right? So I'm going to rewrite a whole bunch of this. 4x to the 5th minus 24x to the 3rd plus 8x. That is not what I meant to do. That's what I meant to do. 4x to the 5th minus 24x to the 3rd plus 8x. And I'm going to write out what I factored them into again as well. This was 2 times 2 times 5x's, 2, 3, 4, 5. This one here was, I believe, 3 and then 3 2's, 2, 2, 2, and then 3 x's, 1, 2, 3. And then 8x was just 2, 2, and 2, and then x. All right. Now, I know that my GCF is 4x, which is really 2 times x. Right. So I'm going to look in each one of my terms, and I'm going to remove those 3 things, 1, 2, 3, from all 3 of my terms and see what I'm left with. Okay? So for example, in my 4x to the 5th, if I take away both of the 2's, there's 1 gone, there's 2 gone, and I take away one of the x's, that is gone as well. What am I left with? I am left with x times x times x times x, 4 x's. I'm going to do the same thing in 24x to the 3rd. I'm going to take away 2 of my 2's. There's 1 gone. There's 2 gone. And I'm going to take away one of my x's. Now what do I have left? I have 3 times 2 times 2 x's, which is going to turn into 6x squared. And then finally, I'm going to take away 2 2's and 1 x from the 8x, and I'm just left with 2. So now, I'm going to put back together my circled pieces here in red, but I'm going to have my greatest common factor pulled out in front because I removed them from each one of these terms. So my final answer here is 4x times my first term right here, x times x times x times x, that's x to the 4th. I know I have a minus sign next, because this was a minus sign right there. And I'm going to minus away 3 times 2 times x times x. 3 times 2 is 6. X times x gives me x squared. And then finally, I just have a plus sign. And all I have left here is a 2. Plus 2. That is called the factored form of a polynomial. All right? Now we can check that this works by doing a very simple thing, and that is exactly what we did yesterday. Distributive property with this function here. If we were to do the distributive property with that function, I would like you to do it in your notes and show me tomorrow that doing the distributive property with this function gets me right back up to this function. So double check that. When we do the distributive property of our factored form down here, we get back to our original equation, 4x to the 5th minus 24x to the 3rd plus 8x. Okay? Once you've done that check, I want you to see how good you are at writing the factored form of a polynomial. So I'd like you to do it for that equation there. What is the factored form of 9x to the 6th plus 15x to the 4th plus 12x squared? Again, step 1, find the GCF by writing out all the factors of all the pieces. Step 2, take the GCF out of all 3 pieces in this case. All right. Take it out. Take it out. Once you have that completed, once you have mastered that, you're ready for your practice problem set next class. So Go ahead and try that one that got it number 3, which you will find right on the bottom of page 493. Once you're ready with that one, you are ready for your practice problem set. Hopefully you have a wonderful night. That is all that I have for you right now. I will see you next class.